So today we're going to start looking at inequalities, and we'll get into those in just a moment. But for right now, I'd like you to just try these 4 warm-up problems. These are just your basic equations that we've been working with since the beginning of the year. So go ahead, pause the video, try the 4 warm-up problems, and then turn the video back on and I'll go over them with you. So with all 4 of these equations, I'm going to show you how to get the answer. I'm not going to take the time to do the check, but if you need to see the check worked out, by all means, please come see me individually during class. So the first one, we have 11x plus 9 equaling 42. We're going to move the 9 first because it does not have the variable by adding the opposite or adding negative 9 to each side. When we do that, we get 11x equaling 33. Divide each side by 11 to get the x by itself, and we end up getting x equaling 3. So the answer to the first one is 3. Number 2, I'm going to switch it to x's because I think s's look too much like a 5. So I'm going to make it 5x equals 7x plus 1 plus negative 2x. First thing I'm going to do is I'm going to combine my like terms. So it's going to give me 5x equaling 5x plus 1. This time I'm going to get both of my variables on the same side. So I'm going to move my variable from the right to the left again by adding the opposite. And what you'll notice is both variables disappear, and on the left-hand side I'm left with 0, and on the right-hand side I'm left with 1. Because those two answers do not match one another, the answer is written as no solution. Our variables disappeared when we solved it down, and the two numbers that I am left over with do not match, so therefore it is considered to be no solution. Number 3. So in number 3, we have 8 times 4p plus 1 equaling 32p plus 8. I'm going to distribute through my parentheses, so 32p plus 8 equals 32p plus 8. You may notice at this point that both sides of the equation are exactly the same, and that should tip you off that something odd may be happening with these equations. So I'm going to add negative 32p to each side because I want to get my variables on the same side. My variables again cancel out, and this time I'm left with 8 equaling 8. I'm left with two answers that match. And because those answers match and I'm running out of room, the answer would be all real numbers. And you do need to physically write out all real numbers. If you want to abbreviate numbers, that's perfectly fine. But for the most part, we should be writing it all out. And the last problem I'm going to do up here in the sky. So 5 times n plus 2 needs to equal 10. We're going to distribute through the parentheses. So 5n plus 10 is going to equal 10. Move the 10 to the other side by adding negative 10 to each side. And we end up with 5n equaling 0. 0 is okay. 0 is just a number. And since we still have that variable, we need to actually continue solving. I'm going to divide each side by 5. And when I do that, we do end up with n equaling 0. And again, 0 is just a number. There's nothing wrong with n equaling 0. So now that we've made it through looking at the warm-up, now we're going to look at inequalities. The only difference between an equation and an inequality is instead of an equal sign, we're going to be using inequality symbols. And inequality symbols are your greater than, your less than, your greater than or equal to, and your less than or equal to. So that's really the only difference. The overall solving equation process is not going to change at all. So just like when we were solving equations, one of the first things we looked at was checking solutions. So we're going to start by looking at checking solutions of an inequality. So we want to know 4 is a solution, so everywhere I see a variable in the problem, I'm going to plug in 4. So 4 plus 2 needs to be greater than 2. I get 6 being greater than 2. Is 6 greater than 2? 6 is greater than 2. That is a true statement. So yes, 4 is a solution to the equation. When I check 0, so 0 plus 2 needs to be greater than 2. 2 needs to be greater than 2. Watch yourself on this one. 2 cannot be greater than itself, and it is not a greater than or equal to sign. It's just greater than. So this is actually not a solution, because that's not a true statement. 2 cannot be greater than 2. Plugging in plugging in negative 1 for B. Negative 1 plus 2 is greater than 2. 1 is not greater than 2. So the answer is no. And again, you physically need to write yes or no. Negative 2 plus 2 needs to be greater than 2. 0 needs to be greater than 2. That is not true. So again, we would write no. So today we're going to look at the 4 operations: adding, subtracting, multiplying, and dividing. And we're going to start just with basic one-step inequalities, just so we get used to working with the sign and realizing that it's not that equal sign, it's that greater than or equal to. The nice thing about inequalities, at least you guys will think it's nice, it's not my favorite thing, but it's very challenging to check inequalities. So we're not actually going to have you check, because the check could range from positive infinity to negative infinity, and any of those numbers in that range could work. So anyway, back to the slide that we're working on. These are the properties that deal with the addition and subtraction of inequalities. And basically, the property just says, if I add or subtract the same number on both sides of the inequality, then I'm good. As long as I do the same thing to both sides of the inequality, just like I do with the same side of an equation, we end up getting equivalent equations. We end up with something that is mathematically equal. So in this one, you can see that my inequality symbol didn't transfer over very nice, but it is m plus 5 greater than or equal to 10. Again, we're not going to check the solution. I'm going to solve this like normal. I'm going to move the 5 to the other side by adding negative 5. So m needs to be greater than or equal to 5. And that is your final answer. There's nothing else to it. But now we need to talk about graphing. Okay. We graph on a number line, and we have an open dot, and we have what is known as a closed-in dot. Your open dot you use if you have greater than or less than symbols. Your closed-in dot is greater than or equal to. That's not a good equal to sign. So greater than or equal to or less than or equal to. You use the closed-in dot. So since we're saying m is greater than or equal to 5, I'm going to go to 5 on the number line. It's going to be a closed-in dot. And this is saying my answer needs to be larger than 5. So I want to include all numbers that are larger than 5. So we're going to draw an arrow to the left. And that's how we graph it. It's literally a matter of picking the correct dot, placing the dot on the number line, and then picking which direction your arrow is going to go. If our number is going to be larger than our given point, or if our number is going to be smaller, depending on your inequality symbol. So I have, forgot to flip the page. I have one for you to try on your own. Take a minute, try it, and then we'll come back together and go over the answer. So to solve the inequality, I'm going to add negative 7 to each side. And I get n being greater than negative 4, because that 7 is larger. So I'm going to come to number 4 on the number line. Since it's positive greater than, it is going to be an open circle. Please make sure when you're drawing those open circles that you are drawing them open enough so that I can see white space in the middle. And this is saying n has to be greater than or n has to be larger than -4. So again, my arrow is going to go to the right. When you create your own number lines, please remember that 0 does not always have to be in the middle of your number line. You can start a number line at any spot. Okay, if I wanted my number line just to go from -4 to 0, I could do that. Okay. The only thing you have to have with a number line is you have to have the same increment as you're counting. So if I'm counting by ones or if I'm counting by halves, I have to maintain that throughout the whole distance of the number line. So again, we're going to look at solving an inequality. This should be an inequality, not an equation. Inequality. This time we're going to start with a subtraction equation, which means we're going to add addition. But again, it's just your basic solving of equations. So I'm going to make this plus -12. I'm going to add positive 12 to each side to get rid of a -12. So -10 plus positive 12 is 2. 2 needs to be larger than x. So it's going to be an open dot at 2. And 2 needs to be larger than x. So that means my x values all have to be smaller than 2. Because 2 is that top line. Go ahead, try this one on your own. It's just like the last one we just worked on. So I'm going to go plus -5 like normal, changing our subtraction to plus the opposite. To get rid of a -5, I'm going to add 5 to each side. So z is less than 6. Open dot at 6 because it is less than. Z has to be smaller than 6, so our line should be going to the left. Now we're going to look at multiplication and division properties. This is where inequalities differ a little bit from equations with multiplication and division. And you'll notice there are two parts to the property. The first part deals with what happens if I'm multiplying by a positive number. Basically, if I'm multiplying by a positive number, nothing changes. What changes is if I'm multiplying by a negative number. If I multiply an inequality, if I multiply each side by a negative number, we reverse the direction of the inequality symbol. So if it was greater than, we flip it to less than. If it was less than or equal to, we flip it to greater than or equal to. And this is only if we multiply each side by a negative number. So looking at an example, in this first problem, I need to get rid of the -3 that's in the bottom of the fraction. So to do that, that fraction means division. The opposite of division is multiplication. So I'm going to multiply each side by -3. That gives me m and -9. Because the number I multiplied by was a negative, my sign is going to flip from greater than to less than. Graphing it, I'm going to have an open dot at -9, and this says m is less than or smaller than -9, so my arrow is going to go to the left. Go ahead, try the second one on your own. So in the second problem, I'm going to multiply each side by a -8. We get k and we get positive 40 because we have two negatives. Even though your answer is positive, the sign of the answer has nothing to do with it. It's the sign that is being moved, or the piece that is being multiplied on both sides of the equation. If that value is negative, my sign flips over. So k is less than or equal to 40. You'll notice I don't have 40 on my number line. I'm just going to cross out 10 and make it 40. So the 9 would be 39, 38, so on and so forth. If you're creating your own number line, you could just start at 30 and count to 50 or 35 to 45, whatever. But I just pulled a standard one down. So k is less than or equal to 40, so it's going to be a closed in dot because it is less than or equal to. And k is smaller than 40. I just want to show you this one because this one's actually multiplying by a positive number on each side. So we're going to multiply each side by a positive 6. So n is going to be greater than 42. Again, I don't have 42 on my number line, so I'm going to scratch out my 10 and make that 42. Open dot, n needs to be larger than 42, so my line's going to go off to the right. We did not flip the sign this time. It was greater than, it stayed greater than, because we were not multiplying by a negative number. So the last of the 4 operations that we need to look at is division. And the division properties are exactly the same as the addition ones. If I'm dividing both sides by a positive number, then I'm golden. I don't have to change anything. If I divide each side by a negative number, I have to flip that inequality symbol again. Flip it from greater than to less than, or less than to greater than. So in the first one, I have negative 10t greater than or equal to 34. I'm going to divide each side by, keep hitting buttons. Divide each side by negative 10. T is greater than or equal to negative 3.4. Actually, that is totally incorrect because I forgot to flip my sign. So I need to flip my sign because I divided each side by a negative 10. So that's going to go to less than or equal to. Negative 3.4 would be about, you're going to estimate, so negative 3.4 would be about here on my graph. And I can't be entirely accurate with my stylus, but I can get pretty close. And t needs to be smaller than, so less than. You go ahead, try the second one on your own, and then we'll go over it together. So to get the y by itself, I need to divide each side by negative 18. Because I'm dividing by a negative, that sign is going to flip from less than to greater than. And y is greater than or equal to negative 4. Open dot at negative 4. Y, or my variable, needs to be greater or larger than negative 4, so my line is going to go to the right. Here I'm just showing you one, just like we did with multiplication. If the value you're dividing by is positive, again, your sign is not going to change, so x is going to stay greater than negative 4. Again, open dot at negative 4, x is going to be larger, so my line is going to go to the right. We have 2 more examples we need to look at. One is just writing the inequality. It is writing and solving, so technically we do need to write it and solve it. And the trick with these is the wording for the inequality symbol. If they want a greater than symbol or a less than symbol, they will actually say greater than or less than. But the wording for the greater than or equal to or the less than or equal to is a little different. So 5 times the number, 5x, and we know we're going to have 45 on the other side. This says 5 times the number, that 5x, has to be at least 45, which means 45 is the smallest number that it can be. It can actually be larger than 45. So at least actually means greater than or equal to 45. And again, I would divide each side by 5. Because I divided by a positive, my sign does not change, and x is greater than or equal to 9. Second one, a number divided by 4, so x over 4, is at most 8. So the highest it can be, the most it can be is 8, which means my x must be less than or equal to. To solve this one, I'm going to multiply each side by 4 to get rid of my division. So x needs to be less than or equal to 32. Last example for today, our handy dandy word problem. So we have $90 to buy CDs. Not that you're going to buy CDs anymore, but you have $90 to buy music from the iTunes store. Okay, for the friend's party. The CDs cost $18 each. What are the possible number of CDs or songs, whatever you want to call it, that you can buy? So $18 per whatever we're buying. We don't know how many of them we're going to buy, and we only have $90. I cannot go over $90. So 18 times however many I buy must be less than or equal to that 90, because I can't go over that 90 limit. I'm going to divide each side by 18 because I divided by a positive number. We're not going to flip the sign, and we would end up with 5 CDs in this case. You do need a label, so if you did switch it to songs or whatever you're buying, please make sure you put an appropriate label. Your homework tonight is actually a worksheet. So you should have that worksheet in front of you. If you don't, you should be able to find it from the either the team calendar or my individual webpage. All of those documents are loaded there for you. If you can't find it or you don't have it or there's some sort of issue with your homework, please speak with me. That's the end of this lesson. If you do have questions on anything that we've gone over today, as always, please, please, please let me know.